Now, whenever you talk about exceptions and templates, you should consider these are two distinct topics. They are combined to each other in this chapter, but exceptions they deal we mostly deal with exceptions whenever we have some, as the name says, some exceptional scenarios. In a program, you can have multiple error conditions or multiple situations that can be gone beyond our control. So those conditions are basically the exceptions. And templates is kind of a generalization of the C++ class framework. We always tend to define a definitive class like animal. Animal is a class, or you can say bank account is a class. You name it. I mean, any object can be represented in the programming world because programming is nothing but a virtual reality. So, whatever you are doing in your real life, you should be able to do everything in the programming world, in the virtual world. I mean, at least you can get a flavor of it and you can meaningfully accomplish a lot of things. That's why object-oriented programming is such an extremely important thing. But when you talk about templates, it refers to further generalization, like in the interface, polymorphism, all these frameworks. What we have done, we are going towards a very generic description of an object, right? That's how we created the inheritance framework. Like you have an abstract class where you describe some fundamental properties that can be accomplished by that class or by the resulting object, and then you can keep extending that class, or uh, you can extend multiple class. We have seen in when we are discussing the inheritance, and then we 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 took care of function overloading, function overriding to realize the polymorphism. So all we wanted to discuss in that framework is how much generalization we can accomplish. Now, templates actually takes this effort of generalization to a new level. We will see that. So we will start with the exceptions. In general, whenever we talk about exceptions, there are two types of exceptions. One is the checked exception that you can check inside your program when you code it. And number two is unchecked. So unchecked exception is nothing but that occurs during the runtime of the program. You have no control on it. Let us say you have you are reading from a file. In C++, I mean any program you read from a file. That's a part of the life cycle of a program. That's part of developer's life. Software developer's life is that implementing the code that reads from a file. What happens? The file is not there. I mean, writing a program that relies on existence of a file is very normal. We assume that a file will be there, but what if it is not there? That is an exception, right? Now you can of course account for that exception when you write the code. You can write you can come up with some exceptional situation where you account for the situation when file is not there. But there can be other situations as well. Say you are validating user's input and the input expected is some number, but user accidentally inputs a string, so you get some exception in relation with the number, because a string cannot be a number. I mean, if you have a zero as a string, there you can come up with some tricks within the program to convert it in a number because it's a numeric string. But what happens if you write ABCD? You cannot represent that as a number, so you will get an exception, and that happens. Like you read something from the database and you get some exceptional situation, or let's say you are trying to connect to a database, or you are trying to connect to a network through your C++ program, and that connection is not there. The internet is gone, or the firewall has some issue, that the ports that were opened in the firewall, those ports came suddenly closed. It may happen, right? I mean, it's a part of the life, it's part of the networking, part of the life. So those situations are accounted for by the unchecked exception. You will often find that due to the unchecked exception, drastically a program stops. It can stop, it can make the program to stop, it can even stop or crash, it can give you some uh, unwanted results. So the goal is to be careful and to accommodate as many checked exceptions as possible, but we cannot, at the same time, we know that we cannot anticipate all possible scenarios, the risks within whenever the program runs. Okay, there are some risks that we don't know, and there are some risks that we don't know that they may exist. So there are a lot of situations. Let's move forward. So exception, as I said, that indicate that something unexpected has happened. So that's what we discussed so far. In terms of the terminology, when we talk about the exception, it's an object or value that signals an error. Within the object-oriented programming, within the C++ programming, exception is an object, or it is coded by a class. But fortunately, we don't have to code it from the scratch. Exception is already a part of C++ language. So you can always find some default exception class and keep extending that class to create your customized exception. Like the string is a class, right? And then you can extend that string object, or similarly you can extend the exception object, exception class, for doing for your customized or personalized exception for a program. Now you can throw an exception from the program whenever you think, I mean, think that you need to throw an exception. Suppose something bad happens. Your typical situation is, let's say you are validating inputs from a user, and you know that user, and you are validating the user against some rules. Let us say you are writing a code for your Department of Motor Vehicles, where your customers, I mean users of your website, they are supposed to include that social security number, and somehow some person included a social security number, let's say 5 digits. It should be 10 digits, and they put 5 digits. So that is the exceptional situation, and we you can handle that by throwing an exception. And the beauty of this process is that when you throw an exception, it's a graceful handling of the error. You can give the feedback to the client, whoever is filling the form, that they have made some mistake in that particular field, so that whenever they fill it out next time, they can correct it. So this graceful execution of the exception can be done by catching it or handling the exception. So you can, in that process, you have ability to interpret whatever happened during the exception. Exceptions, in C++, there are keywords used for exception. That one of them is the throw. Throw is a keyword in C++. Throw followed by an argument, and this is used for throwing an exception. You use the try. Try is basically a block. It indicates that you are planning to handle the exception within that block of code. And catch is catching the exception, meaning catching the situation whenever some exceptional scenario happens. So your it follows by that try block. So typically your coding syntax can be like that, as simple as you create a block, try, and then you write the code. Let's say you are reading something from a file, you complete that code block, and then you write catch, then you put the exception, whatever argument, exception argument. I'm not just a outline. This is an outline, so you don't have to have an obligation to write very technical stuff here. So you have a try, catch, and you write the handling. I mean, maybe you are going to write some output saying that this there is some exception and some details of the exception, and that's your try and catch. Sometimes you used some m- I mean you can have more like more chaining, but this is the fundamental syntax of exception handling, that you start with a keyword try, then you put your code, the regular code, whatever you are writing, you put it under a try block, so that whenever something happens, this does not crash the code, rather it will go to the catch block. And when the catch block is encountered, you have opportunity to handle that exception and then move on. It will not cause the code to crash. That is a beautiful thing. So a function that throws an exception is called from within the try block. There may not be a function. It can be a block of code, simple a block of code as well, as I said. If the function throws an exception, the function terminates. The function does not, I mean, we do not move along with the function. So that way it is terminated, and the try block is immediately exited. A catch block is there to process the exception, is searched for in the source code immediately following the try block. If you include a catch block is not mandatory, but in a I mean, under a best practice scenario, you must include a catch block. So if a catch block is found that matches the exception thrown, we will show you. I mean, I'm just reading, or I'm just like creating a picture of whatever we I mean we picturized here. I'm creating a verbal description here. So if a catch block is found that matches the exception thrown, then it is executed. If there is no catch block that matches the exception, the program simply terminates. So it is always a best practice to include a catch block in the enterprises, in the software companies, or in software development teams. They always do the code reviews, and during the code review, people always find this is a very well known practice to figure out if the program that has been written by someone, that includes a catch block followed by a, I mean, if there is a try block, whether it is followed by a catch block or not. If there is no catch block, then that code is not going to pass. They will ask you to include a catch block for sure. That is because if you don't have a catch block, the program has a potential to fail, because the catch block is the one that handles the exception. Think about the situation. You have a database connection going on, and you have something crashed. You have established the connection, but something in between went wrong and it crashed. And if you don't find a catch block to clear the database connection, uh, basically to reset the database connection, then what happens? Then same program executed by your uh, clients, I mean, whoever is using the program, let us say 1 million clients you have, and 1 million, it will throw 1 million exception because there is a bug in the code, and then there will be 1 million connections that will not be reset. What is going to happen? There will be huge contention in the database, and your entire database will shut down. I mean, for a tiny error, your entire application, entire database will be shut down. So any other application will not be able to consume that database. So that's a dangerous situation, bad situation. So that's why you always put a catch block after a try block. Now, here is an exception. Here is a example, program example. So you have a function that throws an exception. Let's say the function says total days, days, weeks, and then it says if days less than 0 or days greater than 7, then you are throwing invalid number of days. I mean, less than 0 day is not possible if you are calculating the days, something like that. Of that, I mean, half day is possible whenever you are submitting your time, but I mean, at work, but it may not be situation in many other places, many other scenarios. So otherwise, you get a good result. I mean, like you have 7 times week, so number of days you are entering, so you have that. So basically, negative days, negative number of days is not possible. Days less than 0 means -1 days. It's impossible. You cannot do that in any reasonable situations. So there are other example from the same thing, like total number of days. Let's say you have the total days, and then I mean here you throw the exception. Here you are catching it. You see, you have the catch, and then you have the character message. So you are interpreting the exception, and you find the error to be the message, whatever the error message is. That's what you are throwing it. So that's how you can handle the exception. We will go into detail when we write the code. So what happens here, a try block is entered, total days function is called. If the first parameter is between 0 and 7, so here it is. This one, first parameter is between 0 and 7, total number of days is returned and catch block is skipped because there is no exception. If the exception is thrown, function and try block are exited. So basically, you stop everything here in this line itself. In this line itself, you stop because if the number of days is -1, it will not make it to this line. So uh, the catch blocks are scanned for the first one that matches the data type of the thrown exception, and then you execute the catch block. Let us try to write some code. It's a very technical stuff, so we should be writing some code, obviously. So let me open my workspace. Hold on a second. Let me open it up. Where did it go? Okay. I thought I opened it up already. How come it is not there? So let me just open it. File, open folder. Okay. Yeah, here. Here you are. So we have this one. Yeah, this is a blank folder. So let's create a file. Let's say, let's call it exception test.cpp. So that's our first program in relation to exception handling. So what we are trying to do here, we are demonstrating an exception being being thrown and we are catching that one. So we start with usual stuff, that is our initial includes. These are mandatory. We have to do it. Then let's write the prototype. So what we are doing, we are dividing two numbers. And when we divide the two numbers, there can be exception, right? You can divide by zero and that will become undefined. I mean, it's infinity, but in computing it will be undefined. So there will be an exceptional scenario. So let's write the prototype of our divide function. Here you go. So this is your divide function, and then you can do like you can create a your main function, integer main, and then this one return 0. This is your skeleton of your function, and then you can start writing stuff here. Like you have two numbers, that's you want to divide, you want to define the division for, and then you can bring the quotient of the number here. You can define the quotient. Now divide number 1 by number 2 right now, so that you get the exceptions. So that can be done by introducing a try block. So we write here try, and then within the try block, let's define the quotient. So we write it like this, quotient, and then we do the cout. Basically, that's the graceful thing. That's the normal exception expected, that we will get a quotient. That's our expectation. But in reality, if there is any exception, we typically do catch. So we catch the exception, and then we say that we are basically couting. Uh, I mean, we are doing the cout, the exception string, whatever string is there, whatever exception is there, we are doing that. And then you can do just end of the program, cout um, end of the code. Okay, so that way we can create our simple first exception handling. So this is as simple as this. So let us start doing stuff. So we need to have this number one, number two, all this thing going on. But we have to have our function defined. How we define the function? So you can do it in this way. So here you can implement the function like this, numerator and denominator. And there actually you can, if the denominator is 0, then you can say that this is your exception string. This exception string is thrown. You cannot catch something which is not thrown, of course. I mean, that's absurd, right? I mean, you have to throw it. How does it know what is being caught, what it is catching? So here it is. Here is the cue, and the function is throwing an exception string, and the description is error cannot divide by 0. You know exactly what is happening in the function. That way you can find it, and then you are returning from the function, you are returning a numerator and denominator. You are putting a static cast and make it a double. So that's how, because you are dividing two integers, but you are resulting a double. So you can do it in this way, and that is your function. So we can really try to, I mean, we can try it, how we can do this exception handling here. So we have to provide the inputs to the function. So let's say we have to do, we skipped how do we get the input. So let's have our user to provide the input. So let's say I'm writing, sorry, what happened here? I'm telling my user to what happens here. Enter two numbers, and then the user would do cin num1 and then num2. So that way, the user is entering two numbers, and then num1 and num2 will be provided by the user, and then we'll do the division and we'll do the exception handling. So let's try this one. So create a terminal, and as usual, g++ minus o, that is output object. We can do except.exe, and then we can write it as exception test.cpp. So if you compile it and then you run it, you will end up with the two numbers, writing two numbers. So you can say one number is 10, another number is 20. So you get zero point 0.5. It's a very happy path scenario. But what if your numerator is 0, 10 and 0? So you have the exception and it says error cannot divide by 0. So it is called here. So we can say uh, exception catching. Okay. So that way we know for sure that it is in the catch block. Sorry. So let's save it and then we can run it again. So 100 and 0. You can see here it's except t, it should be t. Anyways, just consider, excuse my mistakes here, spelling mistake. But you can see clearly here that we are encountering the catch block. So that's how the exception works. Exception handling works in this very simple way. We do it every day in any programming language, and C++ it is very robust, the exception handling process, and you can see it very transparent as well, because this exception is thrown from the function itself, and you can throw a string as an exception. In many other language, you have to throw a class, exception object, but here you can throw a simple string as an exception object, and you can handle the entire scenario. So that's about your exception handling. We started it. So let's move on. So we have done this, and then we explained it. So um, there is no consideration. So if the exception is not thrown, then we will not simply touch this catch block. There is nothing to catch. So why the catch block will not be executed at all. So predefined except functions such as new may throw exceptions. The value that is thrown does not need to be used in the catch block. In this case, no name needed in catch parameter definition. Catch block parameter definition does need the type of exception being caught. So in our case, it is basically a string. That exception we are getting. So an exception will not be caught if it is thrown from outside of its try block. If you do it out, it's very obvious, of course. And if there is no catch block that matches the data type of the thrown exception. So if you have a catch block that does not have a matching data type, let's say you have um, something different, like you have an integer. So your the thrown exception doesn't have an integer. That's not an exception. That's not an integer. So you will not get it. So a typical example could be like if in this code, in this typical code, let's say we come here and what we do in this function, this is good, but then if we do integer, okay, then you will find that even if the exception occurs, this exception will not be caught because of the type incompatibility. So you write 100, 199, let's say, divided by 0, and you see terminate called after whatever. I mean, it basically segmentation is violated, and you will get very ungraceful exit from the program. So you don't want that because do not your clients do not want to see this type of error message because they don't know what it is. They will think only they will only know that something terrible has happened when they interacted with your program, and that will inspire them not to interact with any of your program in future potentially. So always try to be meaningful when you handle the exception. So we have to throw the same type. Okay, so that's good enough for now. Let's move on. An exception class can be defined. I mean, exception does not have to be a primitive variable. It can be a class. It doesn't have to be a string as well. It can be a concrete class. You can define an exception class, and it can throw an ex I mean, you can throw that class as an exception by a member function. An exception class may have no members at all, used only to signal an error, and you can have the members, and in that case, you can pass error data to catch the block. A class can have more than one exception class. So we will see that. Now, let's move on to a different example. I mean, its code is written here, but we can write it explicitly and practice it so that we know exactly what we are looking for. So where did my VS Code go? Every time I'm trying to do something, I have to open the VS Code brand new. That's not good. Anyways, let's do that. Yeah, here we are. Now, what we can do right now is suppose there is a rectangle class. We can define the rectangle in this way. Uh, I mean, it's a simple programming exercise, but there is a class called rectangle. So what we do typically, let's create a folder. That way we can separate it out. Rectangle. It's not right. I mean, I'm doing something terrible. Rename it. Just write rectangle. Okay. So here I can create a new file and name it like rectangle.h. That is your API for the class. That's the header file in the plain old language. But if you think about millennial programming mannerism, you can tell it as API. So you can write an API like this. It's simple. You see, there are two variables, width and length. You know, rectangle has only two things, width and length, nothing else. Then public is that is your exception class. You can say negative size. I mean, your rectangle is returning some negative size, so that's not realizable. So it's a exception. So you have default constructor here. It's all public. Now, within this class, you can see there is another class, negative size, empty class declaration. So this is a new style. You can see here clearly. This is a new style of program that we have created. Simply, we can do it in this way. Uh, Simply a new style that we have a class within a class. Now we have the rectangle that is our constructor, and then we have two methods, set width and set length. Those are the mutator methods for this class. We have the accessor functions. Those are get width. So you get the actual width here, we need to, I don't know what this bar is standing for, but maybe it is due to some tab, something like that, line space, something like that. Let me clear it out a little bit. Return width, and then you have the get length, you have the get area. So that's all you have here in your rectangle class. Whenever you have a question, please let me know. I will answer the question and answer your questions. So then we have the implementation. These are the prototype functions. We need implementation rectangle dot cpp. That's your rectangle file. Okay. So the rectangle file can be as simple as this one. So we write it like this. What we do, we have to include this header file or the API, I mean API like header file. Then you have, this is the way you can say that set width is a member function of rectangle. That's how you say it. I'm repeating the concept over and over again. Now you have, if the width is greater than equal 0, uh, then you set the width. Otherwise, you just throw this negative size exception. This is an empty class, but it says all about your exception. That's negative size. You are naming it in a way that it is self-explanatory. Then you have set length, and if your length is greater than equal 0, you have the length. That's good. But if it is negative, then you say negative size exception, because uh, the area of rectangle is length times width, and if one of them is negative, then it becomes negative. But why, you can ask me why I did not simply impose the exception on the area, get area, because I did that because you know uh, any what if your width and length both are negative, then area will be positive. But then that does not make any sense, because negative length or negative width is completely unrealizable situation. So that's why we had to write in that way. Now let's construct the main function. So we can say like new file, and we can say uh, rectangle test.cpp. That is your client function, and you can write it in this way, in this simple way, that you can write in this like you have the, you are asking your user to input the, sorry, I did not save it. So here, so you are inputting width and length, and then you are setting the width. At that point, you are throwing the exceptions. Now you are catching this exception rectangle, and then you put the double dot, because this is a member function of the rectangle. This is a member class of the rectangle. So this is the beauty of C++. In some other language, I mean, it is implemented in all other languages this way or that way, but in C++ it's so explicit. You can have a member, you can have a class to be a member of another class. So this says clearly that this is the member class of rectangle class. And then you, once you get that, then you can customize the error message in your way. Whatever you want to throw, you can throw it here. So you can do it here and just write it in this way, and that's your end of the program. So if you want to execute it, let's do that. Let's do some execution. And what happened here? Maybe I have to open a new terminal. Yeah. And then I go to that particular folder, rectangle, and then G++ dash O rectangle.exe, and then rectangle.cpp, and then of course we have to do rectangle test.cpp. So it compiles. So this one we are executing. So rectangle's width, let's say 10, length 20, this is perfect situation, so we are getting it here, and end of the program is encountered, so no catch block is encountered. But if you do width is -10 and length is -20, then you will see negative value as encountered, so you have an error, and that ends the program. So any one of these happens, you get this error. So here you get this alert, and program is done, but no output because it did not, the program did not make it to even this line number 24, because your width is -10. Let's say if you do it like this, width is 10 but length is -2, then it is terminated after calling the length, and then you don't call this thing at all. So that's your program. So that's how you can throw a class as an exception. So this is an example of throwing a class as an example exception. Okay, so that's that. And then what happens after the catch block? So once the exception is thrown, the program cannot return to throw point. The function executing throw terminates. It does not return, it terminates. You have to remember there is no return for the function at all. Uh, it terminates. Other calling functions in try block terminate, resulting in unwinding the stack. So basically, whenever you run the program, you have two levels of memory, stack and heap. So these local variables are stored in the stack area. So you are unwinding that stack area by throwing the exception. If the objects were created in the try block and exception is thrown, they are destroyed. So that is the implication of the exception handling. You destroy the objects whenever you run the program and the program encounters an exception. You can have the nested try block, like you can have try catch blocks can appear within enclosing try block. So inside the catch, you can have another nested try catch block. That's typical if you have some, let's say, file closing, database connection closing application, you will use some nested, you will see that there are nested try catch block that we use. There can be bad alloc when the new operator fails to allocate memory. A bad alloc exception is thrown. General format of this thing is you can catch bad alloc exception. So this is basically your you create a new operator, but it cannot allocate the memory, and then you throw the bad alloc exception. Not that you have to use a bad alloc exception for every new generation, that will be overuse, so you have to be careful about that, what you are doing and what is the potential that your new operator may not have, may not access the memory, required memory it needs. Now C++11 and later, actually, they have no except specifier, indicates that a function does not throw an exception and does not call any other functions that throw an exception. You can say hello, no except. That means there is no exception from this function. It will not call any other function that has the exception. The primary purpose of this keyword is to help compiler produce faster executable code. Exception is slow. I mean, it slows down your process. But it is reasonable to use. But sometimes you don't use. You may have some very obvious function like say hello here. You don't need that. Uh, so that's why you write no except. Now we are going to discuss about the templates, and let's give a break and for 10 minutes, and we'll come back and start talking about the templates. Can you hear me now? Okay, that's good. So we started talking about, let me repeat a little bit. We started talking about the templates, and when we talk about the template is basically a pattern that creates some generalization. And when written, your parameters are left for the data types, and when called, compiler generates code for specific data type. So when you write, you don't specify actually what type of function it is. So you can do it in this way. I mean, you have the times 10 uh, function. You can write it in general. If you don't use template, you can use integer, you can use double, right? That's how you can define times 10. I mean, this is our usual knowledge. But then if you use the template, you see here things are much more flexible. You just define it like template. This is the syntax. You write template, then you put a angular bracket and write type name T. Literally, you write this one. So you have the T. So type name is whatever type name you provide. Now you define the function as T. So in place of integer, you write T and times T num. So in place of integer, you write T. So you define the function in this way. The advantage is when you call it, you can pass specific data type in place of your parameters. So that's the advantage of using the templates. Let me open this up. What happens here? Every time I'm writing something, it asks me to create a new folder. Okay, anyways. So this is our um, Visual Studio Code. Let me create a folder and write templates. So here we can create a code test template.cpp. That's a simple, we're starting with a simple template example. Any other problem you are facing, like I'm not sharing, I'm sharing this and I am not muted. So hopefully everything you can is audible and visible. Okay, so let's write the function template in this way. First of all, like any other situation, we give this example. I mean, we write this one. Then we define the function template. So you write template, that's your keyword. Then you write type name, write T. Instead of T, you could have written R, no problem. You could have done that, but it is usual to write T. And then you write T. Let's say we are doing a square, T number. It's that simple. And you return num times num. That's the square, right? Now you define your main function, return 0, and then you can do uh, now you can do your integers. So you have the integer, user provided integer, and then you can call user provided double. Then what you can do, simply you can ask your user to provide some enter an integer and a floating point value. So that's what you are asking to your user. And here is what you are doing. You can do cin, you can do like that, cin. That way you can input, get the functions. Then you can say here are the squares as an output. So then you do like this one. So what we have done here, we just define the function in this way, and then we start using it as a normal function, as if here we are using as if we are defining an integer function, and we are using this as if we have defined it as a double. That's the simple thing like the template. Let's compile it and run it. We can go to uh, templates. Oh, it is inside rectangle. My bad. Okay. G++ dash O temp.exe, and then we can do template test template, and then if we do that, integer and floating point value, let's say 10 and 11.5. So then you can see that we get square and double, I mean the floating point value. So what advantage did we get here? You can you can accomplish this one with less code, right? You can reuse the code reuse, and you can accomplish this template, this definition of the function with significant less coding. You can have a lot of functions in a code, and sometimes depending on the input type, you may write the code. You tend to write function in different ways. So that simplifies this template framework, simplifies that task. So this is a great utility in the C++. The similar utility is there in Java as well, called the generics, but this is unique. I mean, C++ or Java, I mean, they are so unique that you get a lot of flexibility when you use this type of framework to write your code. But the question is it efficient? Is it slow? Is it fast? I mean, of course, it is memory consuming, because you add more generalization you add to a code, the code will be much more complicated, and then it will consume more times. But it's not too bad. I mean, you can use it for your you can reduce. There is a trade-off. You have some cost comes with the template framework templates, but at the same time you are reducing your programming hours. You are reducing you are accomplishing things with a lot less code. Now we have you can define a template to use multiple data types as well. Now, in a typical example, suppose we are calculating the mileage, mile per gallon, the mileage of a car, gas mileage of a car. Then you can use the template like this. It's very simple, very consistent pattern. You can see template, you can have the type name T1, and then you have two different data types. That's why you are using T1 and T2, two type, but they have the same prefix, the type name, and then you do the miles and gallons. So your T1 and T2 will be replaced in the called function with the data types of the arguments. Maybe you use miles as integer and gallons as a floating point number, double, let us say. So you can, when you call it, you can simply call it using different data types. There are even more examples. The function templates can be overloaded for each type, must have unique parameter list. Okay, so here you have this one, type name, and then you have the sum all, this one, and then you have template type name T1, type name T2, and then you can do sum all, like number one, number two, and this way it can move forward. So that's another example of the template framework. We can come up with more examples as such. So let's move on. We'll find a more definitive example of the template. For example, we can write a program that will basically swap two values using the template framework. Let's do that. Um, so let's again come here, and under the templates, let's create another program called swap.cpp. So here what we do, first of all, let's do the includes without hesitation. We put the includes. Now we define the function. So we write template, you know, type name T. That's common, right? That's the signal to your compiler that you are writing templates. Now you write void swap variables, swap vars, let us say. Then you put T, that is a type. You write uh, var1, variable one, and you are putting the reference T. You do reference of variable 2. Now what you do in the swap function, you define a temporary variable and then you store your first variable to the temporary variable, and then you do var1 equals var2. So you replace var1 with var2, and then you simply do var2 equals temp. This is your classic swap function. Now comes the main function. You can have a lot of different ways. You can have the characters, you can have the integer, you can have the double, whatever you want. Let's say we have two characters, so let's create a main function to demonstrate this one. Return 0, and then we can write this way. We have two characters, first character and second character, and then you can do um, like this one. You are asking the user to enter two characters. The user enters the characters like this one, and then you call swap vars, I mean this function, but then you are using the first character and second character. So that's that, and then you can have that way. Let's say there are two integers, so you can do in this case, you have to define the two integers, of course. So you define the two integers and then the same segment asking the users to enter two integers, and then uh, writing the exact same code for the integers. So we come up with that. You can have the doubles as well. So that's pretty much it is. Let's live with integers and characters. You can have doubles. Uh, you can have strings. No exception here. So let's do compilation. Temp2.exe maybe the executable's name, and the code name is what we wrote, swap. So temp2.exe, and then two characters, let's say A and B. So BA, it is swapped, two integers, let's say 100 and 200, and it will be opposite, 200, 100. So, I mean, swap is a standard function. It's a very popular function. You will see when we will do a lot of uh, algorithmic stuff. Swap is very important, but you can write it as a template. That way, you don't have to alter the code too much. You don't have to write separate swap function for separate purposes. So that's the great benefit of the template. Now you can do the same thing with two types of parameters. Let's say now so far what we have done hands-on is two variable types are the same. Now what we are trying to demo right now, we can have two arguments for a function with two different data type. So let's write it up. Let's do, let's create a file called, let's say, two types .cpp. I'm just trying to be creative in the naming exactly what we are trying to accomplish. I'm just naming the program in that way. So this is our standard headers. Now let's define the function template. Okay, type name T1, then type name T2. So we have two different types. That's why we mentioned, we trigger to the compiler that we are using two different types. So you can say integer largest. We are calculating some largest size of two variables. Let's say, I mean, that's a random choice I have made. Constant, T1, and then reference var1, and then constant T2, reference var2. Any idea why we wrote constant? That's because we are not going to change anything in these variables. They will remain the same after calling this function. If we would change these variables, modify these variables, then we could not use the constant. Now we write if size of var1 is greater than size of var2. Okay, we can say return size of var1, maximum size we are trying to return here. So that's the first part. We should not write code in this way. We should put always the curly braces. That's the best practice. We can do else. Then under the else clause, we can say return uh, size of var2. Okay, so this is your largest size function. Now define the main function, return 0. That's standard way. Now let's define these variables for this function. So we have an integer, we have a character, we have a float, a double. So we want to calculate which one has the maximum size, bytes actually in terms of the bytes. Now we can say comparing integers and an integer and double first, two things at the same time. So you can see that. Then you can do comparing character and a float. You can do it here. So you got it, got everything there. So it's a size means the bytes, how many bytes are there. So if we do that and then temp3, let's say, and then the C++ code name is uh, two types, and then temp3.executable. So if you do that, you see here comparing an integer and a double, the largest of the two is 8 bytes, you know, and comparing a character and a float, largest of two is 4 bytes. So that's pretty much it is. I mean, that's the way you can make the comparison. So you can see here integer I and double. So that's how you can do it. I mean, I is defined here, double is defined here. It doesn't matter how big or small the number is. It's all about what is the memory it holds. So that's what we measured and we compared. So here the advantage again is if we would do the same thing in a non-template way, then we would have written a program that will two functions basically for these two scenarios. But here we could do it with using just one function. So that's a huge benefit of using the template. Template can also be used for overloaded function. Let's do the program, a program for that. So we can do um, overloaded.cpp. So here, and let's write it. So we can do it in this way. This is the one, and then we write template. Again, I mean, it's whenever you write it multiple times, it will be your second nature. So you will be very um, prompt in writing a template program, and you will enjoy it basically. T sum, and then you can write T value 1, T value 2. So we are trying to do the overloaded function template. So then we can do return val 1 plus value 2. That's our function. Now you can, there are two arguments, but you can keep the signature same. What is overloading? You keep the signature same, you keep the return type same, or I mean, whatever way, you can keep the signature of the function same. Um, I mean, name of the function same, but you can have different number of parameters. So here, what you can do, again, template, then type name, then you write t, then you do t sum. There are three variables, of course, t value 1, t value 2, t value 3, and then you can do return value 1 plus value 2 plus value 3. So this is your overloaded function, right? This is the condition of overloading. Now you can come up with the main function for testing this one. So you do return 0, and then you can do your, let's say we start with double. That's our data type. Now enter two values and their sum. First, in the first iteration, let's do that. Now in the second iteration, we can come up with three values. So you can have like this. Here you can see that, I mean, the same function name, you are overloading the function, but your type is quite generic. That's the advantage you are getting. You are, instead of writing four functions here, because if you have integer, you have double. So you have to write two functions for your function overloading, but then there each for each function there are two different variations, integer and double. You could have different, I mean, you can have float as well. So um, so like that, so you are avoiding writing a lot of code. And if we compile it, we should always compile and see if we made any mistake in the program. So we do like overload. That's the program function, I mean, name of the code. So temp4 dot executable. You can write two values, 20, let's say 20 and 22. So you get 42. Then you can write 20, 30, 40. So you should get something like 90. So that's what you get. So you can pass some doubles as well. 10.1, 10.6. So you get 20.7, 10.1, 10.6, 20.7, let's say. So you get 41.4. So it is applicable to integers and doubles at the same time. So that's a great benefit, right? So that's our another example. Now you could do it for the arrays. I mean, you can use it for the vectors as well. The you can use the templates for the vectors. I mean, you can use the vectors. You can create a vector for using the template as well. I'm skipping that example. Um, Now you can have you can have different types of examples around. Let's move on to the slides so that we can move on with with our class. Now we did the function template, where to start when defining the template. So templates are often appropriate for multiple functions. So that's what we talked about, that perform the same task with different parameter data types. So that's the criteria, that's the use case for the template. It can perform the same task and develop functions using usual data types first and then convert to a template. So you can have you can of course add the template prefix. You should write template and then you should write just the whatever is was there uh, in the beginning ahead of any function. We wrote the like this one. We have template, then type name T. This is our prefix. We have to write this before we call a function as template. Then you can convert the data type names in a function to a type parameter. So you can say T type. Remember, instead of T, you could have used or whatever placeholder character is available, you can use that. You can use the class template. That is one of the most important things. I mean, you could accomplish with the templates, you know. So you can have a class template. Classes can also be like templates. Unlike functions, classes are instantiated by supplying the type name. So in case of the functions, you don't use the type name, but for class, you have to use the type name uh, at the object definition when you define the object definition. I'm going to show you. So you have a class called um, grade here. You have private variable. Now your instance variables like t score. So it can be integer, it can be double, whatever you want. This is your constructor. You write grade and you write t. This is the data type. Now you do set grade and then you pass t and get grade will return t. So this is your template. I mean, there is a mistake in this particular program. You should have included, I should have included this semicolon here. Okay, so this is your class example. Now you pass type information to class template in this way. You write grade int. So whenever you instantiate the class, you have to use this type definition. You cannot just use t here because now uh, you are instantiating class means you are converting your code, I mean your framework into a concrete object. So you have the concrete data type in mind. So that's why you need it. So you can do grade double to be like this. Now use ordinary objects once defined. Now, once you define it, then everything is like ordinary. So what is the advantage here? Suppose, I mean, we will be learning in this class eventually. Let's say we are handling a linked list data structure. Now, a linked list can be a list of integer, it can be a list of double, it can be a list of string, it can be a list of character. So there you can define it in a very generic way. That's the I mean that's the scope of the template. So you do template type name t. This is the absolute prefix you have to write to anything. Write a function, write a class. You do this one to denote that you are going to use a template, and that way you can I mean that is the way we could move forward and just define the class here. So when you define the class, when you define your framework, when you define your blueprint, you don't have to be specific about the data type, but you have to be definitive when you when you are going to instantiate those objects. So that's why, I mean, then once instantiated, they can be used as is. I mean, you don't like irregular objects. So you can define in this way, rectangle, for example, then you do the type name here, and then you do this class square. So your templates and inheritance are, I mean, you can have the inheritance when you use the template. The only thing is that your class square should have the same data type, should get the same data type as the rectangle. It cannot be so that you are inheriting a class, but you are for the constructor you are defining different data types, because that will violate your is a condition, right? It cannot be like that. So that's another thing you have to remember. So you have to use the type parameter t everywhere base class name is used in derived class. So here, this type parameter has to be used here. That is one of the mandatory things when you use the inheritance. Whenever you do the reference of the base class, you have to say this particular um, data type parameter. So that's all about templates. So I mean, it's easy, but it can be a little bit tricky sometimes. So I think we have worked out enough example today, hands-on examples. So hopefully the exercises. Let's go to the lab. Let's see what is there in the lab for today. Just take a look, and then so here we are. So if we go to the module, so let's see the labs a little bit. So in the lab 10, we are designing a class called date. The class should store a date in three integers, month, day, and year. There should be member functions to print the date in the following form. So you have to write three different member functions. Now, in this first scenario, it is an exception handling situation. So you have the class should implement the following exception classes like invalid day. So you have to throw invalid day if this is valid. Invalid month if month is less than 1 or month is greater than 12. And you can demonstrate the class in a driver program, means in a main function. You have to write a program with a main function and implement that class. It should be pretty fairly straightforward to do that. If as based on the examples that we worked out, it should be pretty straightforward. Then for the template, I think we have to do design the class date. I mean, what is going on here? In so here um, you can use, I think that's why I wanted to see it, because when I generated I created the homeworks, I thought that there was something that was missing. Probably that is the one that is missing. Let me see. We can edit this homework further so that mm, we can do it seamlessly uh, from the day one. So hold on a second. I am just going to the point where it was defined. It's in the book actually. So you have which one? Which one I wanted to? Oh yeah, that's so this was what I intended to give you um, as your exercise, lab exercise. So let me edit this one. So here, So it should be like you have to write a name class, and let me save it and then we can do it. I mean, we can explain it. So you are writing a class named test scores. The class constructor should accept an array of text score as its argument. The class should have a member function that returns the average test score. If any test score in the array is negative or greater than 100, class should throw an exception, demonstrate the class in the program. So, um, uh, did I use the template stuff here? Um, I don't think we are doing any template here. So that was a mistake. I mean, this is the second example, but I think we should use the uh, template stuff, some template stuff. Let me find a more concrete example related to the template. Okay, that's the better one. It will serve our purpose to learn the template. Let me go there again. I actually, when I created the examples, I mean the exercises, I thought there was some mistake, but due to lack of time, I could not verify it. But here it is. So what we want to do here, we need to write a class template. So you know how to write template, right? Template type name T, that's the prefix, sortable vector. The class should be derived from simple vector class. So you can write a simple vector. Uh, in this chapter actually you will find the simple vector class. So you have to modify it to a sortable vector. So simple vector class can be found here. I mean, I'm just sharing the books. bo- So here you have the simple vector class. So it has a header file. So everything is here. So you don't have to spend time to create this simple vector. It is there. So you can do it very easily. And also template is given for searchable vector. So if you learn this one, then your sortable vector is pretty simple. So you should have a member function that sorts the array elements in ascending order. Um, the I mean, you can use any sorting algorithm. It doesn't matter what you choose. I mean, just search online and find a suitable sorting method, and you have to test the template in a driver program. So when you submit the assignment for each of them, uh, I think the best option is to submit the C++ program and one Microsoft document file with all screenshots. Most of you do that, but some of you just submit the C++ file, but that's not good enough because when we are doing this class, we are also trying to be trained like how to become a good software developer. A good software developer always returns a product, delivers a product with test evidences. So that's how I wanted you to grow with this type of practice. So that's one of the things we want here. And these are the two exercises that I mean we will be doing as lab this week. Now, I think we have covered most, if not all, of the things for intended for today. Do you have any questions for me? So if not, then thanks for attending today's class. If you have any question, don't forget to uh, send me message. You can comment on the video as well. I mean, if it is on Studio, you can comment there. If it is on YouTube, you can also comment there. It doesn't matter wherever it is. It's all accessible to you 100% of the time. It will be accessible to you. So I will be posting this particular video from YouTube because I know that first part was not recorded. So that will be it. Okay, thanks for attending the class. See you in the next week, and hopefully you will be able to submit uh, more exercises, more assignments by then. Thank you so much. Talk to you later. Bye.